So ESA is a club that's at School of Mines stands for Engineers and Scientists Abroad. And so our team, what we do is we plan trips overseas, service projects, so that students can get engineering experience as well as help people out. We were looking for a project to do this summer, and I came into contact with Martin Digler, and he had told me just about the need that was in Liberia, and so that was definitely just something that that I was looking for, just people who were in need, but also people, a place that a project could be done.
My name's Amelia Nelson. We came up with the idea for rainwater harvesting because the students at the school, they don't have access to water and food during the day, and a lot of times they'll have to walk across town and across this busy road to go get water from a well during their breaks.
That's what we wanted to do, was to help them have an easier resource for water. That way they wouldn't have to just send their kids out with a bucket and make several trips, like 200 yards, like multiple times over and over and over again. So we thought that'd be just something that we could do, something that would help us with our engineering stuff. And so we had 4 who ended up going. It was me, Josh Trapp, who was our vice president, Amelia, and Gavin. When we got there, we also had, just prior to leaving, had been informed that they had been donated a generator, and they needed to be able to house the generator in some sort of storage thing. So what we ended up doing was, Gavin is a mechanical engineer. All the rest of us are civils, so none of us had much electrical at all. So yeah, the first thing we did before even working on our rainwater harvesting, which was actually the primary reason we went, we first built this shed. It was made out of concrete blocks.
My name is Gavin Silvera. A few days into our trip, we took our first trip to Monrovia to purchase supplies for our rainwater harvesting system. And that was a very interesting trip. We kind of went into the main city area, and it's a real hustle and bustle environment. And since Elijah was with us, we kind of knew where we were going. But if we were in that environment alone, I don't think we could know the difference between up and down.
My name's Josh Trapp. So we talked with a couple professors at Mines, and they came up with an idea of collecting it off of the roof. And then we designed a little system. So it uses the roof to collect water into a gutter. And then the only problem with rainwater is that whatever it touches and whatever is on the roof is dirty. But after a certain amount of rain, the rain cleans off the roof, and then that water afterwards is clean. So we just have to collect that dirty water, and which we use a 70-gallon barrel for that. And then once that filled, it all went into another tank.
So then you don't have to worry about filters and chlorinization. And so we had this first flush tank that would fill up, and then once it would get full, it would shut off, and then the rest of the water would go into the second tank. The first tank would shut off. We'd had a tennis ball that was it's buoyant. It would float in the water, and so as the water level would rise, it would rise in the pipe. It would plug that, and then the rest of the water that's coming down, now that you have this, the rest of the water is going to just go into the big tank, which was a big old polyethylene. And then basically, then we did kind of like a calculation as to how big we needed to drill a hole at the bottom to let it drain out over a day. So once you get that first flush, the rain's going to stop sometime. And then it's going to start raining again, and you're going to have a new first flush you got to account for. And so according to our teacher, it would be a good idea to have it drain over the course of a day, a 24-hour period. And then it would just constantly, it would fill up or whatever, you'd fill up the tank, it would stop raining, it would obviously drop, it would rain again and fill up, and then you'd start, so that's just how the system worked.